Uh, you we will start with basics of data analytics, and then we had what do you mean by correlation, and then as an example we discussed what is Pearson correlation coefficient, right? With this understanding, with this recall, we will continue with your regression, right? So here I have given you a picture, and this picture tells you, from this picture you can understand a person wants to sell his house, and he wants to decide how much it is worth, how much it will be worth. So how a person will decide means based on the area the house is located, and based on the square feet, and based on the condition of the house, right? You have lot of parameters that decides the price of the house, right? So the parameters which helps to decide the price of the house, you call it as input variables. And for simple understanding, now I am taking only the square feet into consideration, right? Though there are many parameters like the location of the house, the condition of the house, right? We are considering only the square feet, right? So based on the input, right, that is based on the square feet of the house, I will make the output, that is nothing but what will be the price of my house, right? This is so I want to design a system, right? That system, when I just enter the square feet, it will tell me what could be the price for the house, right? If it is so, it will be easy for me. So how do I design that system or design that model? We will take this question, we will take the scenario, and we will try to find the answer using your linear regression, right? So as of now you understand the data is nothing but, we already see what is data. Data is nothing but the values you give for the variables, right? That is what we seen in the previous class. So here you have two variables, x1 and y1. The x represent input and y represent your output. Your x is nothing but the square feet of the house, and y is nothing but the price in terms of dollar, right? With this I put a hold, and I just introduce what do you mean by machine learning. Okay, I told I have to design a model, right? So if I design this model, right, if this model is designed by the machine for me, I have an input, I have an output, I have a set of data. With this data, if the machine is able to design a model, that you call it as machine learning. And in that you have two types of supervised machine learning and unsupervised machine learning. What is supervised? From the word it is understood that you know, you are given certain knowledge about what will be the output. For example, in our previous case, I'm giving you a set of 5 datas, right? In all this 5 data, I tell you what is square feet and what is the price. Let me have a simple example. If it is 1 square feet, it is 1000. 2 square feet, it is 2500. 3 square feet, it is 1800. I need not to maintain a relationship, but I'm just giving some data. So in this way, I have 5 datas, right? So with this 5 data, the machine has to design a model. Here I am telling the input as well as I am giving the output, right? From now onwards, I will use the term target, right? The target value or the label as for my output, right? If it is so, see, if I provide both input and output to learn, right? If I give both input and output to the system to learn, then I say it is a supervised learning algorithm. In other words, you call the data set as a labeled data set because you give the value for the target variable. For example, here I'm giving a set of pictures to the machine, and I also tell them these pictures are nothing but These are the pictures of your cat. So what I will do, I will just remember it. Okay, if this is the if the picture was in this way, then this is cat, right? In this way the system will learn it, and this is during your learning period. And during your testing period, right, it will learn such that if I give an image of a cat, it will tell it is a cat. If I give an image other than the cat, then the machine will tell this is not a cat, because it is learned what is a cat, right? So it will not tell it is a elephant or dog. Instead, it will tell it is not a cat, because I know what is cat, right? This is what your supervised machine learning, right? For example, okay, this is your supervised machine learning. So based on this, you can handle, I have given two simple problems which can be handled by that is your classification, and another is your regression. What is classification? Given, if it here, see here, it learned cat, right? If I was given cat and dog, it will, if I give an image, it will able to classify whether it is a cat or dog, right? That is nothing but sorting items into category. You call it as classification, which we will take up in detail on the next session. The another is your regression. As we seen in the last class, if your target variable is continuous, then you have to go for your regression. If it is categorical, then you go for your classification, right? So with this understanding, we will go what is your unsupervised learning. In unsupervised, I will provide an unlabeled data. That means I will not tell this is your expected output. In simple, I will give you a collection of data, right? And what the machine will do, based on the similarity it finds in the data, it will group it, right? See, I have given a collection of pictures. The machine will try to find, okay, this three pictures seems to be similar, so this is one category, and this three pictures seems to be similar, so this is one category. So it will group it, or in other words, it will cluster the data. So if a new data is given, say if I give another cat image, it will find, okay, it matches with group 1, right? This is what unsupervised learning. And under unsupervised learning, for this IoT, we will learn about clustering, right? Okay. Now, for you to simply understand, I tell you one example. Machine learning highly depends on the data which you use to train the model. Because you consider a simple example. You are writing, you are given a portion for your unit test, right? And you are given coaching for that, right? So if there was a question from the unit 1 portion, you can able to answer it, because you are trained for that. It is you are trained, you learned something from the training that was given for the unit test 1 portions. If suppose I am asking you a question from the third unit or fourth unit which was not covered and the for your unit test 1 portion, you will not be able to answer, because you are not shown before that particular portion, or you are not teach to, you are not thought about that, right? So that is a very typical example for you to remember what is machine learning. The machine learns from what the data you give. So if it sees a similar kind of data, it can respond, right? That is what our machine learning. And now, okay, see, just for us to have a good understanding on what is machine learning and what is supervised and unsupervised, the difference, we will have some simple tryouts. See, we will take the same unit test example. Here the task is you are getting ready for the exam, right? And the set of your data, right? And the set of your data is nothing but the values you have for the training. And how do I measure? I may measure it by having intermediate assessment, or I may have some assignment and quizzes, right? And based on that, if you if I find some errors in that, I try to rectify it, right? So with this example, uh, so a computer program, your machine learning is nothing but a computer program. It learns from the experience, right? It learns from the experience for some specific task T, and you have, and how you measure the performance means you use some measurement, right, to assess the performance. For example, as you have your assignment, quizzes, and midterm assessment, you should have some performance measure to assess the experience, right? Now, the question is, I want a learning algorithm and I have a lot of historical weather data, and from that I have to predict weather, right? Here, what is my task? See, I have a learning algorithm for which I give a lot of historical data, and from that I want to predict weather. Here, what is T? T is your task. What is your task? The task is weather prediction, right? The task is your weather prediction. Okay. Now I have another question. The amount of rainfall in a day is normally measured in millimeter or inches. Suppose you are using a learning algorithm to predict how much rain will fall tomorrow, right? How much rain will fall tomorrow? What kind of problem it is? Is it a classification or regression? It is a regression because you want to tell how much rain will fall. If suppose my question is whether there will be a rain or not, then that comes under your classification problem. For example, I write a learning algorithm that tries to classify my mails as swam and not swam. That is your classification problem. You have yes or no. We take another example. You are working on a stock market prediction. You have tens of millions of shares, right, traded, and you want to predict number of shares that will be traded tomorrow, right? Number of shares, that means it is a value, continuous value. That case, it is a regression problem, right? So with this, given a problem, right, given a scenario, you will be able to differentiate from the data whether it is a supervised or unsupervised. Then based on the problem, you should be able to decide whether it comes under classification or regression. Shall I proceed further or do I want to repeat any point? Ma'am, could you please give one line difference between supervised and unsupervised learning? Okay. One line difference is, for supervised, you use labeled data. For unsupervised, you use unlabeled data. So what is this label? For supervised means you will train the machine with the prediction or with the output. For unsupervised, you just give the input. The system doesn't know what is output. That is what the one line difference. It depends mainly on the data. If you use labeled data, then that is your supervised learning. If you use a data without label or unlabeled to train the machine, then that is your unsupervised learning. Is it okay? Yes, fine. Okay. Now, with this basic understanding, let me move to the next one. See, now you know, here also a set of scenario is given. From the set of scenario, you have to pick which is the suitable learning algorithm. I have chosen which is supervised learning algorithm. See, in the first one, you are given a large data set of medical record and you want to group the patients. I have just given the system my patient's record, right? And the system will group the patient's record based on the similarity it finds in the patient record. That is, it is unsupervised and I'm clustering it. In the second, I have to examine a web page and I have to tell whether that web page is child friendly or adult. That is I classify, right? That is comes under your supervised. Then again, you are given a crop data for 50 years and you want to predict next crop yields. Then that is your and that is your regression. Then given a data of 1000 medical drug and you have to discover the types of patient. Again, it is clustering. This is for you to give an idea of what given a problem, how do you identify whether it is supervised or unsupervised, and whether it is classification or regression problem. Okay, this is definition of machine learning. We have seen it is a ability to learn without being programmed explicitly, or you will not program, you just give the data set and you pick a model, it will learn it to classify it. We will see how it is being done with picking your linear regression. Now, in the last class, we ended with an information that y is equal to what? Okay, both A and B have classification, but okay, you want to go for previous slide. This one, okay, I think you are saying about this slide. Both A and B have supervised and unsupervised. Okay, here I am telling what you want to do, right? See, I will give you a web page and I tell you the label that it is child friendly and adult. When I give a web page, I will also tell that this if the content was if the content of the web page was this and this, then that is child friendly. If the content of the page is no this and this, then it is for adult. This kind of information will be given for training. So I am telling the features of the web page, as well as if this are all the features, then this is meant for child, and this are all the feature, this is meant for adult, right? So it is a labeled data. In the first case, I just give you a set of datas, right? I just give you the patients with heart disease data, but I'm not telling you what I'm just giving you and asking you to this patients will have different set of treatment. All the procedures I have given, I have not given this is what the treatment, this is what the treatment you have to classify. I have given you the records. You just when you try to find a match, you find match that this set of persons are treated with this way, so I group them one together. These are all the patients having this treatment, so I group them together. You don't tell it the label explicitly. Based on the similarity, you group it. So it comes under your unsupervised. Okay. Now, okay. Is this equation resembles your straight line? Mx plus b, right? Now, let me see what is linear regression. Your linear regression is nothing but drawing a straight line, right? You draw a straight line relationship between your input variables and your output variable. I'm going to take a single output variable, and for examples, further discussion also, I will take single input and single output variable. Right, so you want to find a suitable straight line between your input and output variable. Okay, I know what is the equation for the straight line. So what I want to find, my algorithm or my model, or I have to with my training data, I should be able to find the coefficient, suitable coefficient for this b0 and b1, because I know this is the slope and this is the y-intercept that decides my straight line, right? So I have to find the coefficient for this b0 and b1 so that I form a proper straight line that separates that helps me to derive my y value. Right? You can better understand this with an example. I will get back to it later. Okay. Um, just look at this example. This is a housing price prediction, right? As we discussed, the house price is given in the house price is my response. That is, this is what I have to predict. Right? We introduced two variable. One is your explanatory variable and another is your response variable. The variable value which I am interested is response, that is the price. The explanatory variable, that is the value which determines my responses here. So this is square feet and I have given a set of previous data, right? In the previous data it is given if the square feet is like something around 2104, then my price is 460, right? And if it is some 1416, then it is 232, right? So I have some set of data and this set of data is marked as point here. I have to find a suitable line, right? Why I need to find a suitable line means, see, in the data set, it is given for 2104, 146 and so and so, right? If suppose I want to find if my square feet is 750, what will be the price? What I will do is, I just try to find an intercept on the straight line and try to get what could be the value in my price. So if it is 750 square feet, if I am using this pink line, then the value will be 150. If suppose if my algorithm devises such a line, blue line, then my price, I will think my price as 200, right? So this only for this kind of prediction, I need to draw a line. My efficiency depends on how I draw this line successfully so that my predicted value is near to the actual value, right? How my predicted value is near to the actual value. We will see it in elaborate. So with this example, so now we know what my intention is, why you draw a line and what you want to understand. I want to find my B0 and B1. In other words, let me from now onwards, let this coefficient or you call it as parameters. From now onwards, we do not call it as coefficient. Instead, you call it as parameters. I want to find the parameter value of beta naught and beta 1, which are the parameters. And what is this epsilon? This is, you call it as residue or the error term. See, when I draw a line, when you draw a line, see, when I draw a line, right, it will not correct in, not all the points lie on the line, right? So there may be some points up and below, right? So this is the deviation. This is the deviation with my prediction. I predict the point to be here, but actually my point lies here. This you call it as error term or residue, right? I have to design a line such that it minimizes my error term. Okay, now, so now I have transformed this straight line equation into a linear regression model. My intention is I have to find this parameter value with the way this error term should be minimized. Okay. Now, so how do I determine this parameter value? What I do is I will randomly try some values for this B0 and B1, right? And I try to find the estimated value or expected value given the X value. I know what is my input, right? So I will give the input value and I will try some random values for this parameters and I will get the estimated value. Once I get the estimated value, from the training data set, I will know what is the actual value. From that, I will find the deviation. See, this is y term, this is the expected estimated value. This b naught and b1 I have calculated, and this is your input value. From this you find the estimated value, but this is your, this yi is your actual value, right? So you find the difference and you square them up. Actually why you square is the reason is I'm not going into depth, right? So as of now, you understand. For better clarity to expand it, you just square it. And our intention is you have to find the minimum error term, and this you call it as least square method. In simple words, you always how you calculate error, the actual value you have minus the observed or minus your estimated value, right? That you square it, and you do it for all your data items, and you have to find them such that you have the minimum value for each. This is your least square method. Okay. As an overall picture, I will be given a sample data. I have to find a straight line. I can use simple statistics. We will see how. I can use simple statistics and I can find B naught and B1. But this will not help me if I have a large data set, and if I want my machine to construct the one with minimum error, then I have to go for machine learning, right? There where I have to find this parameter beta naught and beta 1, right? This you call it as unknown parameter values. I have to calculate it. How I calculate it? I calculate it using this regression model, where it is nothing but your straight line equation plus your error term, right? Okay. See, this is a very simple example. This is simple statistics. I was given a data set which we discussed in the class, in the previous class, that based on the advertisement, how you get intention to buy product, right? So if I see one advertisement, number of cars sold is 14. So this kind of I have given 5 datas, right? With this, to separate this 5 datas up, right? Why, if I draw a straight line, if here I was not given a question like if I have seen a what will be the answer if I have seen 5 advertisements, what will be if I have seen 2.5 4 advertisements. If you draw a straight line you can find it, right? So you, this is an equation for finding your b1 and b naught and b1. Once you calculate your b naught and b1, you can have an estimated line. It is a simple statistics. Your x bar and y bar is nothing but your mean. Mean is nothing but summing up all the values and divided by total number of samples. This is okay when I have simple data set, but I cannot assure that I'm getting a appropriate line that splits my data. Now we will get into the model. So before getting to model, this is the line that you derive through your model, and this may be the points around actual points. So the difference between them is nothing but your error. Okay. Now, so far I was just telling you linear regression in layman terms, right? So how you term it with respect to your ML, or that is in your machine learning, or when you apply your data analytics, how you term them? You term them as your hypothesis. The hypothesis is nothing but you propose some explanations with the evidence you have, right? That is what your hypothesis. So this is what the hypothesis. This is nothing but actually your straight line equation, right? And the parameters or theta naught and theta 1, this is what you have to find. And what is this cost function? This cost function is nothing but your error term. You look at this. This is an error term. This is your actual value, and this is your observed value. You find the square of them, and you find the difference, you square them. And why it is normally, why you have 2m, That is a separate part. You understand as of though you do it by, or you normally you divide it by m, right? Here you do it by 2m. This is what your cost function, and your intention is you have to find minimum cost function. For further discussion, I will not get into this minimization because actually it comes under optimization. I will not discuss this. I will be discussing how to find the parameters and just throw a light on what is cost function. Okay. This picture is not a new to you. This you have seen already in your correlation coefficient. See, if you just draw a straight line, what you do in correlation coefficient, you say it is zero, right? There is no relationship. So see here, I have given a set of lines, right, for the data points, and you have to find what kind of straight line matches your requirement. You see here only one data lies. It is not going to have a give it in your right way. Here it was much closer, right? You were, it is good, it is well and good. And here you were able to cover almost all points, and this is another way, right? So you can, and for our discussion we are going to consider only the line equation. This is for your understanding how you virtually separate your or virtually draw a line in your data set space to have a prediction. Okay. This is the same example which we discussed. So the choice, your intention is finding the suitable value for your theta naught and theta 1. Okay. Now, with this understanding on I will just have a recall of what is linear regression. With this understanding, you're just going to solve some simple problems. It is not a complicated one, but see, what is linear regression is nothing but given a set of data, you try to find an optimal line that helps you to make a future prediction about your output, right? That is what your linear regression. So now consider a problem uh, of how well a student does in her second year of college, right? So what is the data I'm using means, let X be the number of A grades, right? And that student receives in the first year of college, and we like to predict the value of Y. What is Y means? The number of A grades that he may get in the second year, right? So each row is one of your training samples. Actually, this is given to you, right? It is given to you. It is a supervised learning because my intention is I have to design a model to predict this Y, what the number of grade the student will get in the second year. This is the data I had from my previous record, right? Okay. Now I have to design a line like this. I have to find the value for theta naught and theta 1. I find theta 1 naught and theta 1 such that it will separately maps for this data set, right? Okay. Now, the simplest question is, how many data sets I have here? You can post it in the chat box. The simplest one, or the number of samples I have here. Yeah, that's good, right? This, you may ask why this may be the simple question, but this is the first step for your calculation. That is, given as the number of samples plays an important role. Okay. Now we go for the next stage. I think I skipped certain questions. I will post it to you later. I have a continuation of this question, but it was not over there. I will post it later. Okay. Now this is the second problem. Um, that you have find a recursive relationship between your foot length and the height of a student, foot length and the height, right? Your foot length is your response and height is your explanatory, and they have used 33 students, that is 33 samples, to derive this particular equation. That means here your theta naught is your 10.9 and theta 1 is your 0.23. Now my question is, one student in the sample has 73 inches tall with a foot height of 29. What is the predicted foot length for the student? If, see, I am given an equation, right? I have given an equation and you are asked to find what is the predicted foot length. What is the predicted foot length? How you know? You know, you are given the x value. What is the x value here? Good. Good, Manju. X value 73. Now you calculate and tell me what will be the predicted foot length value. In parallel, I do the calculation. So, what I have to do? I have to do 0.23. Yes, somebody have posted. Yes, it is 27.69. Right. So the answer was 27.69. As per your regression line, it was 27.69. But what was the residual value? So what is the residual for the student? Residual is nothing but the error, the difference. I was telling that if it is 73 inches, it has to be 29 centimeter. But I have come with a regression line that tells me it has to be 27.69. So what is the error or residual? Yes, that's right. Okay. You have to find 29 minus. Okay. Okay. So what you have to do is you have to find 29 minus 27.69. Okay. Then now this is the question. See, for this you have to make use of this data set, right? This is the okay. What I do is I will share my entire screen so that you can see everything. Okay. See, the question is they have given you a cost function. So what is cost function? Now I elaborate you in elaborate. See, I will tell you a simple story, then I will come to this cost function. Okay. The thing is, I want to buy 5 items, right? You assume that I want to buy 5 items. I'm going for a market. In the market, I find n number of shops. Let me assume there are 7 shops, right? And all the 7 shops provide me the just 5 items, right? So how do I think to which shop I will go and purchase? How do I make a decision? How I will make the decision means in one shop, one item is cheaper and some other items are not cheaper. In another shop, an Y item may be cheaper and some other item may not be cheaper. So what I do, I put a rough calculation, right? In the first shop, I will get a quotation. In the same way, I will get quotation from the 7 shops, and I will have one predict. I will have some ideas. I will make a guess. Okay, this is. I will make a budget. Okay, this much amount I can spend for an item A. This much amount I can spend for item B. Right? I try to make a comparison from the quotation. I get it from all the shop, and then I decide, okay, if I move with shop X, that will be cheaper for me. Then I will go to that shop and I will buy, right? This is the normal scenario you do, right? This is the same case with your regression line. Before you draw a line, what you do, first you make what you just make an assumption for the value theta naught and theta 1. I just term it as parameters. First, I will make one parameter value for theta 1 and theta naught. If I have this as my parameter, right? What will be my error function? What will be my errors? What I do, I apply this theta and theta 1. With this theta and theta 1, I apply all the x values in my data set. For example, in this example, what I have four data set, right? So for all this four data, right, for this all four data, if I were given with theta and theta 1 value, I know what is the equation, right? So in this equation I will apply the x value and I will find what is my estimated y value, and I know what is the actual y value. I will find the difference and I will add all the differences together. That is, I will sum it up. I will have one value, that is cost function, right? Cost function of having theta naught and theta 1 as so and so. This is the cost function. In the same way, you go for another theta naught and theta 1, you will get another value. So you will have a n number of cost functions, right? You pick the one that gives you the minimum cost function, right? I hope you could have better understood it. Now you are going to do that. See, here I have chosen the parameter value to be 0 and 1, right? And you tell me if this is the case. Yes, if this is the thing, what will be my cost function? If I choose the parameter to be 0 and 1, what will be the cost function for this given data set? The cost function is nothing but you square the difference, you sum it up and divide it by 2m. You people do it and tell me the answer. Let me share my screen so it will be easy for you. Okay, where is it? I temporarily stop presenting and I will present my entire screen so that okay. Now you will be able to see my entire screen. I will put you the problems on both the sides so that you can able to get it right. Okay. See, here is the data set and here is what you have to find. What you have to do is 0, 1. So you apply how you get this value. As your theta not a 0, you have only theta 1. So you do theta 1 into x. First time you do it is 3, then you do it with 1. You have altogether, you have only this. You add it up, you will get 8. 8 divided by 2m. M is 4. So 2m is 8. So 8 divided by have anyone come up with the answer? Let me check the chat box. Okay. No one has come up with the answer. I repeat it again. See here I have given the question theta naught plus theta 1. J is 0 comma 1. That is your theta naught is 0 and your theta 1 is 1. Right. Now what will be your estimated value for first data set when you apply it? Here you have 1. So 1 into x it is 3. What you have here is 2. So what you will have 3 minus 2 you have 1. 1 square, that is here you will have the value as 1. Then you go for the second. In second means again you will have 1, 2 minus 1, 1. Again you have 1, 1 plus 1 you have 2. In the third case it is 0. So you will have again 1. It is you will have it as 1 square, again 1. You have totally 3. Now you have 4. When you up 4 minus 3, 1. That is 1 square. Again you have it as 1. So you add it up. All the things you have it as 4. Right? 4 divided by 2m. M is 1, 2, 3, 4. So 4 divided by 2m. So 2 into 4. 4 divided by 8. You have some answers in point. Right? This is how you do. For the second, okay, now, okay, this example we have seen. Then the next question is, suppose you want to set theta naught, right? In the case the theta naught is minus 2 and theta 1 is 0.5, right? So what will be the estimated value for h of 6? That is, I want to know if my input is 6, what will be the predicted value y? See, I have given input as 6 and I want to tell what is my predicted value. How you do? You apply the equation. So minus 2 plus 0.5 into 6.5 into 6 is 3. So minus 2 plus 3, you have 1 as your answer. I'll go for the chat box. Okay. Right. Yes. So now you see, actually you have done a prediction, right? In the second question, you have done a prediction for the given input value. In the first question, you have calculated the cost function, right? Okay. This is what a linear regression. It is not a new term. It is just your line drawing. For given set of data, you draw a line so that you are able to make a good prediction. That is what your linear regression. Okay.